be calling our next speaker in person of Opeyemi Stephen from Gaia AI to speak to us on from ChatGPT to ChainGPT, shipping autonomous agents on Ethereum. Please, a round of applause for him as he comes on stage. Thank you very much.
My name is Opeyemi Stephen. In the eyes and mouth of some people, Opeyemi Bangkok. For some, just Bangkok. For others, Egbo Adugo. Right? Nice to meet you. Say nice to meet you too. Okay, now we do have the crowd, and today I'm going to be talking to you guys from ChatGPT to ChainGPT, shipping autonomous agents on Ethereum, right? But before that, I wanted to say let's get straight into the video, but not TikTok. How does this move? Cool. A little about me. Obviously, Opeyemi Stephen, Bangkok, whatever. I'm Global Ecosystems Lead at Gaia. Gaia is a decentralized artificial intelligence network infrastructure that enables you to ship your own code, to ship your own AI agents, to spin nodes, and to be able to inference your GPUs at any time and anywhere in the world. Before that, I was Dev Innovation Lead or Developer Innovation Lead at Fuel Labs. Previously, I was TCM at Consensus as well. Worked with, on projects with MetaMask and Linear. Sorry, can I get water? My voice is a little hoarse. And yeah, I'm also CTO for Danezo Trade Africa. It's our startup here in Nigeria. We're a loan and remittance platform, and we provide loan and remittance services to small-scale enterprises and small businesses. I'm going to need that water, please. All right. Yeah, at the end of the day, I'm a friendly neighborhood guy. If you see me anywhere, feel free to say hello. Feel free to walk up to me. Yeah, that's that about that. Okay. So why decentralized artificial intelligence? Because we can't just go from ChatGPT to ChainGPT without understanding whatever it is that we're doing, right? I'll say it in a few words, right? Chatbots talk, right? And agents act. And what I mean by acting in this case is it's not just reasoning, right? But holding a wallet and transacting on chain. If we're talking about autonomous AI agents or shipping Ethereum agents, right? I'll show you the minimal architecture, or the aim of this is to show you the minimal architecture that makes this real and the exact steps that you can follow after this session to be able to build your own. We'll have a little starter code which you can scan and then build off on. I built like a template for you guys as well. So just a precise, reproducible playbook. So why decentralized artificial intelligence? First of all, builders need control, right? You don't want to build stuff and then you have no control over what you're building. Everybody complains these days about Google. Everybody complains these days even about OpenAI. As a platform, I think there was something in the news the other time of, all the secrets you tell ChatGPT, the please and the thank you, that it could be used, in a legal case. True or false? True or false? Am I talking to a crowd here? Guys, true or false? Cool. So there was all of that talk, and builders need control, in essence, right? They need clarity, and they need the ability to be able to act on chain. So first, ownership and portability is one of the reasons why you need decentralized AI. You should be able to run your inference, where it makes sense, either on your own personal node or even if it's a rented one. And you should be able to move without rewriting your app, right? Secondly, trust and privacy. We mentioned the legal case or the legal precedents Sam was talking about. Thank you very much. Sorry, just a second. All right, cool. Yeah, it's better now. Let's get back to it. So, like I was saying, right? Trust and privacy. You need to be able to audit the path from prompt to action and to keep sensitive data as a builder with the explicit allow list that you have. That's the second reason why you need decentralized AI. Now, third, on-chain actionability. That's just big grammar for you should be able to do things on chain, right? You should be able to give your agent, whatever AI agent it is that you're creating, a bounded wallet and policies so that it can sign and it can call contracts safely. Control, transparency, and action. If you're looking for 3 words of why you need decentralized artificial intelligence, control, transparency, and action. Please, what did I say? Are we hungry? Please, now, you should have eaten before you came now. How you come to party and you're not going to eat? So, control, transparency, and action. What did I say, please? That is what decentralized artificial intelligence unlocks. Now, let's see the minimal architecture that makes this practical. So we're going to slow it down. I don't know if you can see this. I think it's visible enough. We're going to slow it down now and define what runs where, right? How actions are gated, and we'll give like a plain English version because a lot of the time people talk a lot about, oh, the jargon is too much. Oh, I don't understand it. Oh, it's not clear. What we aim to do here and what I've taken, my personal mission is to simplify everything as much as possible for you guys, right? So let's start with the first thing there. You see agent runtime, right? Agent runtime is simply your app or your service. So this is like the minimal architecture of what, your Ethereum agent should look like. You understand? Now, your agent runtime is your app or your service. Now, what does it do? It plans a step and chooses a tool. Think, if you want to say something like the contract or the agent should read the price. You understand? Or, if the delta is more than 1%, then update. All those your if and else statements, all those your conditionals and everything, that's where your agent runtime and your app or your service lives, right? What does it do at the end of the day? It outputs a structured intent. So if I'm explaining to you like you're 5, what your agent runtime simply means, this is just the planner that is saying, I think that we should do X, here's why. Now, how many of you have gone through like your normal ChatGPT, especially with GPT-5, for instance? You see those thinking stages, right? Where it's telling you it's thinking, and if you click it, you can see those different stages that is taken. That is what your agent runtime is. Is it understandable? Is it understandable? Please make my work easier. Sure you understand. Tabak me was party. Please. Is it understandable? Thank you very much. Now, let's now go to the second path, which is where I'm going to be shilly, right? Which is like your inferencing layer, your Gaia nodes. You understand? This is the inference-only node. And what does it do? You can see there, right? It converts prompts, these prompts that you have put there, to structured outputs. It does not hold your keys. It does not touch your chain. You can self-host or you can rent. So I was with Hyperbolic at some time too. Hyperbolic is also a decentralized artificial intelligence network. We inference GPUs. People could rent GPUs as against paying for this really, really, $20. Not everybody has $20 to float a project. Or if you're like a big company that wants to scale. But people could rent GPUs, right? So that is where your Gaia node comes in, or your inference layer comes in. It doesn't hold the keys, right? It doesn't touch your chain. You can self-host it, or you can rent it. The endpoint is also portable. The endpoint is portable. Now, if I was to explain this to you like you're 5, right? What your Gaia node or your inference layer simply is, it is the calculator or the translator that helps you, the planner, think, but it cannot spend your money. It cannot do anything outside of what it is that you want it to do. Understandable? Capish? Cool. Let's go to the third part now, right? Which is your signer or your policy layer. So we've listed 2 parts already. Your agent runtime, which I said is the app or the service. Your inference layer, which you can plug in something like Gaia to, right? I'm going to just say plug in Gaia because, that's what pays the bills, right? And then the third one is the signer or the policy layer. Now, this is what we call the safety gate. You understand? Separate process or microservice, right? It holds your private key. You can enforce whatever policy that you need before signing. You can also allow a list of ABI methods. You can allow spend caps. If you say, when the price hits so and so, as my agent, help me invest $20, or help me invest $10, or help me invest $5,000. Let's assume you are building like a trading agent or something. So this is where all of those instructions are going to live. You understand? All the safety gates that you need, even your rate limits as well, it lives on your signer or policy layer. You understand? If the intent violates the policy that you have set, what is going to happen? It's going to reject, that task and ask that, oh, let a human come and review this particular action. Is that clear? So if I'm explaining to you like you're 5, this model would not sign anything unless you ask it to, or unless the signer itself does that. You understand? This is the adult with the wallet, if I'm explaining to you like you're 5. So we've talked about the planner saying, oh, I think we should do this and this, right? We've also talked about the calculator or translator that will help the planner think. Now, this signer or policy layer, it is the adult with the actual wallet, money spending, Olu maintain. This is what you have here. Do you get me? Now, the planner can ask, but it's the adults that will now say, oh, okay, yeah, this applies. Let us spend so and so, or let us sign so and so transaction. Is it clear? Is it clear? Now, the fourth thing you have is your RPC provider. If you're an alumni of Web3 Bridge, or you work with Web3, or you're a builder, you would know what RPC means, right? Who's a builder here? Who's a builder here? Who's a builder here? So for 10,000 Naira, right? Let's do quick giveaway. I like my talks to be interactive. What does RPC mean? Who knows? Oh, now all of you are raising up your hands, have you? But no, let's do it. Who knows what RPC means? Yeah, big man. Sorry? Can you guys hear him? What did he say? Right or wrong? Right or wrong? You just won yourself 10,000. Please see me after the talk, yeah? This is where you clap, by the way. Even Tinubu does not give you money for free now. All right, let's get back to it, right? So for the number 4 part, you have your RPC provider, right? Could be standard HTTPs. So when you send that signed transaction, to maybe Sepolia, right? You can configure your primary and your fallback RPCs. Nothing should really be custom, on this layer. So again, putting it like you're 5, right? This is the road or the post office, you understand, that carries out, is the road or the post office that carries out your already signed envelope. So let's assume you're sending a letter now. You've written your letter. You've said, I love you to that babe. For those that went to boarding school in my time, right? You've said, I love you to that babe, right? And you said, oh, let's help you deliver the letter. Obviously, there was no social media then. I'm not that old, though, please, right? But this is the one that now carries it. All of the things that you need, and now you are putting your transaction on the blockchain, whether it's signing, whether it's making investments, whether it's sending tokens, right? Now, after that, the 5th layer is now the contract or the minimal rights method. Now, you can call things like, maybe you write a method like your update value method, right? This is going to emit an event. And then when you emit that event, you can verify by reading storage or listening for that event. I mean, everybody who has run 1 or 2 integrations before knows what it means to call an endpoint. If you're like a front-end guy, I think even back-end guys know it, right? So this particular contract layer is like the vending machine. You understand? It's the right signed coin, and the button will give a predictable result because you've written the rules and you've told it what to do. So when you call the endpoint, you expect something, either success 200 or what? Error 404, Abi, or 500 or whatever. I forget those codes now. But you know what you expect at the end of the day. It's either successful or it rejects and tells you the reason why with your error message. So if you're going to put this flow in 6 bits, right? You have your user triggers, and then from there it goes to your agent plans. From there it goes. Gaia would return the intent via the inference layer, right? Your policy would validate, right? Your signer will build, or it will sign, or it will send whatever you need it to send, right? And from there, you can now log your transaction hash, and then you can confirm the block, on your Explorer. That's how that is supposed to work. So from idea to action, all you are going to need to do in these 5 stages, all of what this encompasses, right? Number 1 is to think. That is what the runtime would do, right? And then you decide. That is what the node would do, the inference layer is going to do. And then you check your rules. That is what your signer or policy layer is going to do. Check the rules. And then you pay, or you sign, or you do whatever it is that you need to do. And then your machine would update, and then you keep the receipt, and you can check it on whatever Explorer that you're using, right? So there's something that you need to also know, which is observability. The observability will happen on the Explorer side of things. You have to keep that paper trail, which is what essentially the blockchain helps you to do. So you make sure that you keep that paper trail and maybe log like what we call the correlation ID, right? You log that ID, you log probably the transaction hash, you log the policy decision, so that should you need to check, later for discrepancies, you can be able to do that without any problems. I think I've bored you guys a little bit, so let's go to the next slide. So this is the agent lifecycle. This is how it works, right? So from trigger to plan to think to check to sign and send to verify, right? So trigger is your user action, your cron or your webhook. The plan, the agent to propose the intent. What are we doing? Why are we doing what we're doing, right? And then you think. Your Gaia or your inference layer, it could be, I'm not going to shield others, so it has to be Gaia. So your Gaia node is going to return that structured output, and then you check, with your policies and your safety measures that you have put in place. You understand? Your allow list, your spend caps, your rate limits, you sign and send, wallet signs, RPC broadcast, and then you verify. You can log your transaction hash, and then you can check whatever it is that you want to check. Please, is this clear? Do I have the crowd or have I lost the crowd? Is this clear? Thank you very much. So now, so a quick part to shipping, yeah? Because we do not have a lot of time, I made a starter repo, and you can use this QR code if you want to experiment on this actual project, right? You open the repo, you scan the repo, you set your environment keys, right? And then you can run locally. I also put scripts, right? I also put some demo scripts and some safety scripts for you so that you don't end up going the wrong way. So obviously you open the repo, and that just means that you're picking the toolbox, right? Oh, sorry, my bad. So obviously you open the repo, right? Sorry about that. You open the repo, and then you set your 3 environment keys so that the script would know that you're on the test network, right? It's a throwaway wallet, and the contract address, right? You label the jars so that nothing gets mixed up. And then you install. You install by running locally, obviously npm install. If you're a builder, you should know this by now, right? npm install, and then you also install the demo agent scripts that I put there for you. This would give you that environment for you to be able to play around, right? For the sake of time, we're not going to be able to go into like the code, but that was why I took the time to explain how these things work, so that when you are on your local machine, when you're looking at the repo, and then it also has a comprehensive README that will take you step by step through all of the things that you need to do as well, right? You can leave a GitHub star if you are impressed with it, and also you can also contact me on Twitter or whatever if you have problems or office hours. I'm totally down for office hours at any time of the day. I think my voice is going again. You load this up. Shows you what you need to do, your chain starter. So let me explain some of the things that are there real quick, then I close, right? So your chain starter agent, what you see there is your chain starter agent, which is the folder, right? This is just the blockchain agent starter kit that I have created. It will demonstrate how AI agents can safely interact with Ethereum smart contracts, right, through a policy layer. That's what the thing is. Also, what does it do? It takes you from AI agents to policy gates to Ethereum transaction, right? It will show you the complete flow from AI decision making to on-chain execution. So when you get into that particular repo, I have listed all of those things, right? I think I should have pulled it up anyways, my bad. But if you get into that repo, you would see all of it. Your chain starter kit is there. You check what it does for you, and you'd see the complete flow from like AI decision making to like your on-chain execution. Now, the key components of what you are going to find there in that particular folder. The key content you are going to find there is your agent oracle, contract. This is a simple oracle that would store a single value for you. It has an update value method, right? Or a function, you can call it a function as well, that AI agents can call. And it would emit events for transparency as well because you're working with the blockchain, right? Another key component that is there is your AI integration, which is the demo agents.js that you see there. The second one the script that you have to install. This is going to connect your AI endpoints, like Gaia, for decision making. It can also fall back to mock data if you don't have any AI service configured or integrated. That's what the demo agent.js script is for. It will also demonstrate how AI agents can propose blockchain actions for you, right? Policy layer as well, which is the third one. It contains your function allow list that is going to only permit specific contract functions, right? It also gives you like your gas price caps in case you're trying to spend gas and stuff. And then you also have like your blockchain execution layer, which is going to sign and send transactions to Sepolia testnet. Sepolia money is not real money, please. So you need to keep that in mind, right? It uses ethers.js as well for modern Ethereum interaction. And it also provides your transaction verification and status reporting if you need to log incident reports and all of that. So you might ask yourself, like, why does all of this matter, right? First things first is safety, right? Policy layer would prevent your AI from making dangerous transactions. You understand? Scalability as well, right? If there are no patterns, you cannot have real DeFi protocol or smart contract doing things autonomously for you. So you have to have that policy layer. If you are familiar with Liquid, I don't know, who knows Njoku here? Njoku the dev. If you're familiar with Njoku's products, Liquid, right? It has that policy layer if you go into like the nitty-gritty or if you have spoken to him about the product. So this is important because you need those policies to be able to put safety gates so that your AI does not run riot and do, what it is not supposed to do for you or then start hallucinating and stuff like that. Also, transparency is another reason why this matters, right? All AI decisions that you are going to make with this particular project is obviously going to be stored on chain. So it is transparent for all to see, and it maintains that blockchain ethos, decentralization, and transparency. All right, dynamic parameters adjustments too for DeFi protocols. You should be able to change things as things go. You should not just have a point A to point B AI agent, whereby you cannot stop in the middle and say, oh, let's do this, or let's do this, or let's add this. You understand? Your AI rails should, as much as it can run autonomously, it should also be able to say, oh, I hand over the reins to a human. You should also be able to take control, at any point in that particular user journey, right? Understood or not? Cool. So this is not just a demo. It's something that can help you. If you use this starter agent kit, it can help you go to production-ready patterns for building your own artificial intelligence agents that can safely interact with blockchain protocols. So from this, you can spin up an agent that can interact with Solana. You can spin up an agent that can interact with Cosmos. You can spin up an agent that can interact with, there's like 1,000,000,001 protocols these days, right? So you could use this to, get started and get building. All right. So this would position you also. It's going to give you that nice journey. It's going to give you that nice experience of getting your hands in the weeds with artificial intelligence, right? So you should use this. The README is going to explain it to you properly. Anyways, so at the end of the day, right, this is the ethos of decentralized artificial intelligence. I cannot finish my talk without letting you know that you should own your intelligence, right? You should start today. You should start today. Own your intelligence. People shouldn't be the ones in control of whatever you do with your data. It is very, very important that you do so, right? And in the words, thank you. You can follow me here, right? Let's build autonomous on-chain agents. My handle on Twitter is DEVVGBG. But if you just run a quick search, Opeyemi Bangkok is the name. Don't ask me why Bangkok, anyways. And in the words, I'll leave you with the words of a great philosopher. So you know that we have a lot of philosophers, right? And to encourage people, it's always nice to leave motivational quotes. True or false? True or false? So in the words of the great philosopher, right? What's this? What happened? Oh my days. I don't see it. But let me leave you with the words of this great philosopher, right? His name is Crown Uzama. How many of you guys know Crown Uzama? He's also popularly known as Charlie Poppy. So in the words of the great philosopher Crown Uzama, aka Charlie Poppy, all this my Web3 boys.
Alright, party.
Start today, keep building. Pass like that. Thank you very much.